Hey everyone, in this video we're going to get started creating our own library in Fusion 360. Thanks for joining everyone. If you have checked out the first video, it was a very basic introduction to Fusion 360 PCB. Now PCB is printed circuit board, and this is amazing functionality to have in Fusion 360. But what we're going to do today is we're going to get started understanding more about how the libraries work and how to create our own components. While this isn't typically the first step you would take while learning, what I found through my journey to learn PCB is that a lot of the stuff that I wanted to do just wasn't in the library. So I want to make sure we understand some of the basics on creating these components, the symbols, the different types of devices. So that way, whenever we hit that roadblock of needing a component that's not in there, we know how to make it. So again, we're going to get started by making sure we have our own project set up. And note that I created a library subfolder. While you don't have to do this, it's important for me to make sure that I organize all my files and data so that way it's easier down the road. So now that I have that project open up in my data panel, I'm going to go to my file dropdown and select New Electronics Library. This is going to start a brand new untitled library. And this is where we're going to create our devices, our symbols, our footprints, and our packages. These are all the different pieces that go along with all of the functionality in Fusion 360 PCB, which comes from Eagle. We won't need to have all the individual pieces inside of Fusion 360's library. For example, we don't need the 3D packages. It's not a requirement if you're making a printed circuit board, but we will need to have a symbol and a footprint that's associated with a device. So we're going to take this basic look, and when we get started, there's nothing in here. It's completely untitled. And what we want to do is I'm going to start by saving this. It's going to ask me where I want to save it, and I'm going to put it directly inside of that library subfolder. However, I'm going to call this my lead library, so I know that it's from the YouTube series. Now that my library is saved, I can start making my symbols, my footprints, and linking them to devices. We're going to start from the very basics, and we're going to begin by creating our own 1206 resistor. Now this 1206 is a surface mount design. It's an SMD or SMT, depending on where you are. And it's going to be something that's already in the library, but I think it's important to understand how to make even a very basic component. So I'm going to start by creating a new device. My new device name is just going to be a 1206 chip resistor. Now you'll notice when you start this that everything is going to be capital and everything will be next to the character before it. There is no spaces. So if you want to add spaces, you'll need to use things like underscores. So in my case, if I want to have space, I can go ahead and add it. And you notice here I forgot an S, resistor. There we go. Now that we have this, we're not quite done, but you'll notice the screen changes a little bit. What we have here on the left-hand side is going to be where our symbol's located. And then over here, we're going to have our footprint. A footprint is going to be what actually gets created on our PCB. And then in the top right, we're going to have the 3D or the package. And then we have some information at the bottom about chips and things that are going to connect to different pins or different locations on our device. So now that we have this chip resistor, I need a symbol and I need a footprint. For the symbol, I'm going to select symbol and notice that it's empty. I don't have anything in here yet, so I need to create a new symbol. Now this can be done again just like we did our device. We can simply create that new symbol name, or if there's another symbol in the library that works for what you need and maybe it just doesn't have the correct footprint for your circuit board, you can import that. So for the resistor, I'm going to import it, and every time we do, it's going to want to save the library first. Now it's going to give us access to all of the available libraries that we already have. And for this, I'm going to go down to resistor and I'm going to simply select RUS. Now you'll notice here that it says name value and it has the typical symbol that we would expect for a resistor. I'm going to say OK. So now we have this RUS symbol. Notice it has 2 pins and there's no description here. It's empty. When we use the resistor, the name is going to get created automatically. So as we begin to populate a board, it's going to have an R1, R2, R3. And the value is something that we set when we're designing our schematic. So for example, if this was a 1K ohm or a 5K ohm resistor, we would set that value when we're creating our schematic. So right now, just the name and the value, these are going to stay open. But what we can do here is we'll notice that there is a crosshair in the middle of each of these things. When we select it, it allows us to start moving it. If we hit escape and we notice on the right hand side, if we just select it without moving it, it gives us the inspector or the properties of what we selected. The text in this case is just name, and it tells us what layer it's going to get placed on. When we take a look at the values, you'll notice that it's going on layer 96, the value. If we take a look at each of the lines that are associated with this symbol, or if we box select all of them, you can see that each of them are on layer 94 for the symbol, and it gives information about each. And then you'll notice that we have these two little icons, pin 1 and pin 2. The pins are the important part because it allows us to route, to actually connect traces between different elements. But now that we have our symbol, we can go back and we can take a look at our device, and if we double click on it, there's still nothing here. Well, the symbol needs to be associated with the footprint and the design. So once we go back to our device, we need to select Add Part. Now when we select Add Part, the only thing that we have is this resistor, so it's the only thing we can select. But we say OK, and then we can place it inside of our device. Now, if we were making something that was more of a logic circuit that had a lot of these different symbols, then we could continue to place them. But in this case, I just hit Escape, and then I can hit OK or Cancel to get off of this. Now that we have a symbol associated with it, you'll notice that here we have the symbol, and at the top level, we have the device. There's a couple other things that we want to make sure that we understand. On the right-hand side, we have this value section, and you'll notice it's kind of behind this information here, which is unfortunate. But what we want to do is we want to make sure that we turn this value on. Now, the reason that we want to do this for a resistor is because it's a component that we need to manually set its value. This is true for resistors, for capacitors, and some other types of devices. Now, in most cases, what we want to do is we want to leave it off. If we have something like an end FET or a BJT transistor, we want to make sure that that's off because that isn't really getting set. So now that we have our symbol inside of our device, we need a footprint. Now the footprints are where it gets a little tricky because depending on what you're doing, depending on if you're making a surface mount resistor or something that's through hole, then that's where you really need to spend your time and attention making sure that you know exactly what you're making. Of course, a 1206 resistor or a metric 3216 resistor is something that's already in the library, but we want to make sure that we understand how to make these, so we're going to start from scratch and make our own. If you take a look at the description of this video, there's a couple hot links in there. One is to DigiKey, and this is just one of the available 1206 resistors. Now, it's important that we find the components that we want to use because some cases you might notice that the pad layout or some of the specifics about the component are going to be a little bit different. This is especially true when you get into components like an SD card slot. The pin layout might be reversed or the pad layout might have keep out regions. So it's always a good idea to make sure that you at the very least double check the components you're ordering to make sure that their ideal pad layout is the same. Now, when we look here again, what we're doing is we're taking this surface mount, this SMD or SMT, sometimes it's one way or the other, and it's a 1206 package. Now, it's a standard package. Again, metric is 3216. And what we want to do is we want to understand what that actually means. So when we're talking about the 1206, it's a standard size, it's a standard pad layout. This is generally done with a 0.9 millimeter by 1.6 millimeter pad, and there's 2 millimeters of space between. If you take a look at the details of this resistor, you can download the datasheet, or you can select the option to view the datasheet by selecting it here. And then you can go down and find out more information about the size. So for example, here we're looking at, once again, 1206. It tells you the overall size. In this case is 3.1 millimeters by 1.6. And then the height of it is 0.55. So if you were going to create a 3D model of it, you have all the information you need here. Now, oftentimes the pad layouts will be inside of these spec sheets, these PDFs. Not always, but in most cases you will find them here. What we want to do from here is we want to go back into Fusion and we want to begin creating that footprint. So we're going to go into footprints. Notice there's nothing here yet, and we'll go ahead and we'll just create a new one. I'm going to call this a 1206, and I'm going to call it, once again, my chip resistor. I'll use underscore to keep it consistent. So we'll say okay, and it brings us into a different area. So now we're inside of the footprint creation. We can go back and forth between symbols and between footprints and packages and devices, and each of these areas are going to give us a different tool set. So now that we're building our pad layout for the resistor, we need to understand a few things. There are many different options that we have as we look through here, but the main area that we're going to focus on is this create area. So we can create an SMD pad. We can create a PTH, which is going to be a pad with a through hole. We can create an array for both of these different types of pads or through holes. Then we have information about name, line, text, and so on. So what we're going to focus on is creating a pad. And this can be done by manually drawing it or by placing this. All right, so we have to, again, remember exactly the size we need. I'm going to set this at 90 degrees. And the pad that we need is going to be, in this case, 1.6 millimeters, and it's going to be by 0.9 millimeters. You can use this drop down and you can oftentimes find ones that are pretty close. So you see here 1.67 by 0.8. That's likely going to be the standard. Whenever we're designing any of these footprints or symbols, we always want to be mindful of the origin. Now that crosshair that's in the center of my screen is going to be the origin. As soon as I place these pads and I say okay, notice that they're on the screen, but we have no idea how far apart they are. Well, you do this by going into your grid settings. You want to make sure that you're either using a 2.54 millimeter grid or that you're using the 0.1 inch grid. Now, either of these are going to be perfectly fine, but make sure that you have some consistency. And if you want to see the grid, you can turn that on. And now we can see exactly how far apart they are. But we need to make sure that we have a specific spacing between these pads. Otherwise, it's not going to work at all for us. So again, this is the origin point. And what we want to do is we're going to hit escape and then we're going to left click on the first pad. This is $1. That's just a default name that's given to the first pad. And notice that it's at minus 2.54 and 0. The 0 is fine because it's based off the center of the pad. The minus 2.54 is fine because it's based off the center of the pad. But we need to make sure that we have 2 millimeters between the pads in order for this to work for our 1206 package. Now, if we just enter 2 millimeters, we're not taking into account the width of our pad. Now, in this case, it's 0.9. So we have to be mindful of how thick that pad is. So half of our 0.9 is 0.45. So we need to make sure that we add that to the distance or the spacing that we're working with. So in this case, we're going to have minus 2.45. And then on the other side, we're going to do 2.45. Now remember that when we're doing this, this is from the center line. So effectively what we've done is we've added that spacing, but these are still way too far apart. Now remember, we need 2 millimeters between them, but we're going from negative to positive. So each of these has to only be 1 millimeter. So on this one, we're going to make sure that we go to a minus 1 millimeter, and the other one will be a positive. Now what we should see is that they're minus 1.45 to the center and positive 1.45 to the center. And that's going to give us that 2 millimeter spacing between plus the thickness of 0.9. This is going to be the most critical step in the process. If your symbol is a little bit off, it's not going to matter as much as if your pad layout's off. If you try to make a PCB and your pads aren't the right size, your components aren't going to fit. So make sure that you take extra care and pay close attention to the spacing and understand that when we're creating these pads, we're going from the center of that pad. Now, a lot of times the detailed drawings, the PDFs that you'll find for these different components, they'll be referencing corners. So you always have to take into account the thickness of the pad. So from here, we have the pad, but we want to add a bit more information. So what I'm going to do is I'm going to start drawing lines. The lines have a couple different types to them. Right now it's set to the default square bend, and what I'm going to do is I'm just going to start drawing. When I do this, it's creating a box, and once I'm done, I can say OK. Now this box is actually going to be the actual outline, the solder mask that we put around our different parts. But we have to be mindful of what layer it's on. So right now it's on the top layer, and if we look through our layers, you'll notice that there are other different layers, top values, top names. And as we go through here, you see that we have keep outs, restricts, drills, milling, measurement document, and references. So when we look at these different layers, some layers are going to get included in the PCB. Some layers are only going to be visible to us. Things like 49, the reference layer, will be visible inside of our layout, but it's not going to go onto the circuit board. So what I want to do is I want to make sure that I put this on a layer that is going to be created. And in this case, I'm going to put it on 21 T place. So that T place, and if you happen to click on this and it starts moving, just hit escape. But that T place is going to be the top layer, and it's going to allow us to put it on this specific layer that'll get included when we're creating our PCBs. So this is important, again, to make sure that all these are right and that we understand exactly what is going to get created. Now that I have this placed, I want to move it a little bit closer to the resistor. So you can see that the line goes from minus 2.54 to positive 2.54. So this is essentially our X and our Y's. If we modify one of these, for example, if I go from 1 to 1, you notice that this 2 is moving this point right here. And what we want to do is we want to create a rough outline for where this resistor is going to fall on our circuit board. So what we're going to do is it's going to go from our, let's say 1.5, and 1 is going to be okay. And then we're going to go from minus 1.5, and we'll set this one at 1 and see where it comes. Now we don't need to have a full border for our resistor. We actually don't even need these sidelines. So what I'm going to do is I'm going to select, and then I'm going to press delete on the keyboard to get rid of these two. And then I'm going to mimic the same values with that other line. So again, we can go from 1.5 to minus 1, and this is going to be minus 1.5 to minus 1. So now when we create our PCB, we're going to have these lines that help us identify where the resistor is going to fall. There are other things that we can add, such as the name. Now, if we just click on something, for example, a pad, it's going to place the name of that pad. Now, with a resistor, that doesn't really matter. What we really want to see is the resistor name and the value, which will get added later on. But if you want to add something specific, you can always add text. And in this case, I'm just going to say custom R, custom resistor. And then I can place it, I can change the size of it, I can do whatever I need to. And then if I want to, I can go in, I can select it, and again, I can choose what layer I want it to be on. So top place will allow me to figure out where that's going to go. So now that we have our layout, we have our symbol and our footprint, we need to make sure that everything in the devices is accounted for. So back inside of our chip resistor, on the right-hand side, it's not here yet because we haven't linked it to anything. So we're going to go to this new drop-down. We're going to say add local package. This is the only thing that we have in here so far. So we're going to say okay. And now we've got our custom resistor. We've got the pads. It's automatically generated this border for it. And we've got the lines that we added. You'll notice that there is a warning, this triangle telling us that something still needs to happen. What we're going to do is we're going to select connect. Now this is important because we need to connect the pins, the locations on our symbol, to the locations on our pad layout. Now with a resistor, it's not a big deal because this thing can be flipped around, but this step is important because this is how we're going to draw our traces when we create our schematic, and how Fusion 360 is going to know to create the traces on our PCB based on, in this case, our footprint. So in this case, it's going to look for similarities between the name on our symbol and the name on our footprint. In this case, it's going to go with 1 to 1 and 2 to 2, and that's completely fine. Now that those are connected and mapped, we're going to save this. So this is the first thing that we've added to our library, but we still can't use this library in anything yet. We need to make sure that we add it to the available libraries. We can always come back and edit and create more devices, more footprints, and all this different stuff, but we need to make sure that we have access to it when we're creating our new components. So I'm going to open the library manager. Now inside of here, it shows all of the ones that are in use and all the ones that are available, and I can use this add from team. When I select add from team, it's automatically going to go into the current location that we are in the data panel, and I can select my library. As soon as I add it from team, you can see here it's my lead library. Version 3, it's just how many times I've saved it, and now it's in there and it's ready for use. So back in the untitled document in Fusion 360 that we have by default, I'm going to go into a new electronics design. I'm going to create a new schematic. We're not going to save this because we're going to go through this entire process, but I just want to make sure that when I go to add part, that I do see my available lead library here. If I expand it, I've got my chip resistor. You can see here, it's got our value, it's got our custom R. I'm going to say okay, and I'm just going to place it. I'm going to say okay, and then I'm going to move to my PCB document. When I move to my PCB document, what we should see is our custom resistor. I can move this onto our circuit board, and now what we have is we've got a board that has our custom R text that we added. It has our lines, and it has our 2 pads. And those pads are connected to what we saw on our symbol. Now remember, that's the important bit, because when we go to start creating these nets are going to allow us to draw between the pins on our symbols, and it'll transfer that when we go into our circuit board in the PCB, and it'll understand what those connections mean. So once again, this is not our project yet. What we really wanted to make sure that we took away from this is how we can work inside of the library, and how we can make a basic symbol, and how we can make a basic footprint. Now, with the information that you have, you should be able to create a new device. You should be able to create a new symbol or import a symbol. And the process of creating that new symbol is very similar to what we've already done. If we double click on our resistor, all you really do is you need to draw lines and add pins. We will do that process. We're going to apply it to something a little bit more standard. We're going to be importing a 3D model from a manufacturer, and then we're going to create the pin layout as well as the footprint for that, and we're going to associate it to a 3D package. So we're going to go through that process, but I want to make sure that we understand at this point, we created a new library, we can create a device, we can create or import a symbol, and we can create a footprint, and we know how to link all those things together. As long as you understand that process, then we can move on and we can start creating more complicated examples in our library. But if you had any difficulty with what we did here, make sure that you review the process and understand how to link all these different elements together, and how to at least create a basic footprint, making sure that you understand how to place those pads and draw those lines and change the layers that they're on, because that will be extremely important downstream. One last thing that I want to do is I want to move back to my schematic, and I want to make sure that we can use this value option with our resistor. So in this case, our value is going to be 1K, and it displays at the bottom. You'll notice that it's calling it a U1 because we didn't associate the name with the number or the letter R. So that's something that we didn't do because we're not planning on using this resistor. There are plenty of resistors in the library, and we don't need to really worry about making that. But I just wanted to make sure that we understood the process of what that actually means. So you can see here that bringing a chip resistor in and setting it to 1K from the library It's a little bit different because it automatically makes that R1. We added that 1K to it, and it just looks a little bit different because it's designating itself as a chip resistor rather than one that's a typical through hole or typical one that you would see in sort of a hobbyist kit. So once again, we're not saving any of this. We are making sure that we understand the library aspects of it, making sure that we can create that new library, and making sure that we understand all the different elements that get linked together. Once you're there, make sure that you do always save your work, save it often if you're planning on keeping it, and then we can move on to the next lesson where we'll get into making a more complicated example of a component. Once again, thanks for joining me. I hope you guys picked up a few tips and tricks if you're just getting into PCB design. And stick with me because we're going to go through the entire process on how to create a circuit board using all of our different symbols and components and understanding the process of taking that and making a file that we can actually export and have a PCB made.